Now see the first question. ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA. AC is the diagonal. Then show that, see, it is given that S is the midpoint of AD, R is the midpoint of CD, Q is the midpoint of BC and P is the midpoint of AB, and this AC is a diagonal. Now we have to show that SR is parallel to AC and SR is half of AC. This SR is parallel to this AC and is half of AC. Okay. Now second thing which we have to prove is PQ is equals to SR. This PQ is equals to SR, and third thing, PQRS is a parallelogram. This PQRS is a parallelogram. Now in this question also, first you will write what is given to us, then you will write to prove, then you will start the proof. So given and to prove you have to write yourself. Now see the proof. Now see triangle ACD. ACD. In this triangle it is given that R is the midpoint of CD and S is the midpoint of AD. It is given to us, and we know that by midpoint theorem this SR will be parallel to AC and SR will be half of AC. So we can directly write, therefore by midpoint theorem SR is parallel to AC and SR is equals to half of AC, because this is a triangle. Okay, so this is how we have proved the first part of our question. Now name it as equation number 1. Now see the second part. In triangle ABC, in this triangle also P is the midpoint of AB and Q is the midpoint of BC. Okay, so again in this triangle also by midpoint theorem this PQ will be parallel to AC and PQ will be half of AC. So we have written it, PQ is parallel to AC and PQ is half of AC. Now name this equation as equation number 2. Now from equation number 1 and 2 what we can see is SR is parallel to AC and PQ is also parallel to AC. That means both the lines are parallel to same thing, that is AC. So they both will also be parallel. So from equation 1 and 2 we can see that SR is parallel to PQ or PQ is parallel to SR. Okay, and see in first equation SR is equals to half AC, and in second equation PQ is also equals to half AC. In both the equations right hand side is same, so their LHS will also be same. So from equation number 1 and 2 we can also say that this PQ is equals to this SR. So here we will write PQ is equals to SR. So this is what we have to prove in equation number 2, part 2. Okay, now see the third part. In third part we have to prove that PQRS is a parallelogram. Now in quadrilateral PQRS, it is given that, we have proved it above that PQ is parallel to SR and PQ is equal to SR. Here we have proved it in our second part that PQ is parallel to SR and PQ is equals to SR. So here we will write proved above. Now since one pair of opposite sides are equal also and parallel also, therefore we can say that PQRS is a parallelogram. So we will write, since one pair of opposite sides are equal and parallel, therefore PQRS is a parallelogram. Thank you everyone. If you like my videos, please like, subscribe and share my channel, and stay connected with A1 study classes.